In this question, we have a set of test scores that are normally distributed. Now, for the empirical rule, we really just need for this to be bell-shaped, but it says normally distributed, which is definitely bell-shaped, with mean 74 and standard deviation 6. And we're asked to use the empirical rule to estimate a percentage of scores. So what I'll do for 37, let me write that down here. So this is number 37, and I have my bell-shaped distribution, and we know that the mean is 74, that falls in the middle, and the standard deviation is 6. So one standard deviation above 74 is 80, and two standard deviations above is 86, and three standard deviations would be 92. And then I'll go in the reverse direction. And 6 below 74 would be 68, and then 62, and then 56. Okay, so what we have is our center, which is 74, that's the mean, and then I've marked 3 values above the mean and 3 values below the mean. And so what the empirical rule tells us is that we can determine the percentage of scores that fall a particular number of standard deviations away from the mean. So first of all, in 37, we're looking at the percentage of scores that fall between 68 and 80. And that's one standard deviation from the mean, so that's 68%. It doesn't have anything to do with this 68. We know that within one standard deviation of the mean falls 68% of the scores. And that is actually given on your exam. So, so you don't have to worry about memorizing the number 68 in particular. And that's the answer for 37. Now let's take a look at 38. So let's start fresh. And we have 74, 80, 86, and 92, and 68, 62, and 56. All right, now we want the percentage of scores that fall between 56 and 74. So, where is that? Here's 56, and here's 74, which is, this is a bad drawing, but 74 is at the middle. So we want this area. It's almost half of the whole graph, but it's not quite half. What we know is that 1, 2, 3. So from 3 standard deviations below the mean to 3 standard deviations above, we have 99.7% of all the scores. So what we're going to do is say, well, we have half of that because we're only going from 56 to the middle, not from 56 all the way to 92. So I'm going to take that 99.7, I'm going to divide it by 2, and this gives me 49.85%. And so that's the answer for 38. So we're taking the information we have, we're manipulating it a little bit. In 39, it says to use the empirical rule to estimate the percentage of scores that fall below 62 or above 86. So let's draw this again. This is number 39. And okay, so I've got my distribution again. Now we're looking to find the percentage of scores that fall below 62, so here's 62, or above 86, and here's 86. So now we're not looking for the middle, we're looking for what's in the tails. And this is pretty common. We'll be doing this a lot in the second half of the semester. So, how do we determine the percentage in the tails? What we're going to do is say, well, what percentage would fall in the center? And 62 to 86, that's 2 standard deviations below the mean to 2 standard deviations above. So by our rule, that is 95% of the values. So how much is in the tails? Well, what's left over? So we're going to take the 100% minus the 95% from the middle, and that gives us with 5%. And that's our total. So if I wanted to know how much is just in the bottom tail, that would be 2.5%. And in the top tail would also be 2.5%. Together it makes 5%. So what's the answer to the question is 5%. We're not looking at how much is in either tail. We want the total of the two tails. So we want them to fall below 62 or above 86. So either way. So 5% of the values fall in one of those two categories. So the answer is 5% for that. And that's how you do those 3 problems.